Welcome to my talk. I'll be speaking today about building information systems using event modeling. My name is Bobby Calderwood. I'm the founder of Evidence Systems, and we are a Confluent partner. And I build systems. I prefer functional programming and closure, but I have a strong emphasis in my practice here at Evidence Systems, as well as in my past career in building event-driven systems that are made out of events, event sourcing, CQRS, etc. And today I'm going to be speaking about Apache Kafka, probably no surprise there, but specifically around using Apache Kafka to build APIs and services. So this is, Apache Kafka is immensely capable for streaming ETL, analytics, and kind of the big data backend use cases. But now I'm going to be talking about specifically applications and services, user-facing applications, internally facing applications and services, etc. So we're pulling Apache Kafka all the way forward to be kind of the backbone for these apps and services. And a lot of what informs this particular talk is a particular client story. So at Evidence Systems, we use this design philosophy. We use Apache Kafka to build our own internal products, our customer-facing products, but we also have a professional services business. And on this particular engagement, we were working with a large organization. We happen to be partnered with Confluent on this engagement. So this large organization was partnering both with us and with Confluent. So we worked closely together with Confluent in this engagement. And this company was a large tax preparation service, and they were rewriting kind of their core applications, their tax preparation service, their tax engine, kind of all the core bits that made their business go. They already had this sort of event-driven core data platform. It was based in Apache Kafka, and they wanted to expand on that success. So they articulated this vision of wanting to build this ecosystem of event-sourced applications and services with Apache Kafka sort of at the core of the whole thing. So they brought us in to think through how to design that application. So obviously their infrastructure was taken care of with the Confluent Streaming Data Platform, Apache Kafka specifically. And they needed help on the application design side. So we brought to them sort of a philosophy of event-first application design. They had some of this already developed internally and organically. And they recognized that as we do, that event-first thinking is more accurate to modeling their business domains than like database-centric thinking, for example. Our brains are designed to think in terms of narrative. Our businesses are designed around promises we make to our customers, how we fulfill those promises, decisions we make, right? All of these key events in the course of our business processes are really what they're made out of. Additionally, if we build applications and services around databases, and then as an afterthought, we'll sort of bolt on this notification thing and we'll send events to other people. I've never seen that work very well because applications and services don't dog food their own events. They don't eat their own dog food in terms of their events. When they're built on top of events, the quality and the completeness of those events are organic and flow out of the application design process. And so when you send events out into the world for other applications and services to consume, you know that they're complete, you know that they're of high quality. And finally, integration is always a concern, especially in an enterprise setting. Somebody always wants your data. Somebody always wants to see how you're doing stuff. Someone always wants to get at that stuff. So again, if you leave that to an afterthought, if you design your database first and then, oh man, someone else wants my data, I've got to ETL out of my database and all that. Don't do that. Just build applications on top of events, and then customer engagement and outreach, marketing, analytics, machine learning and AI, security and compliance auditing all naturally flow out of your application design. They're very easy to add in the future and add features. There are drawbacks, of course, to this event-first application design. First, on the infrastructure side, most programming languages, mature data stores, design tools, etc., promote and assume sort of this database-first design philosophy. So event first is catching up quickly. Obviously, we've got the great Kafka ecosystem here that's leading the way. But functional programming, thinking about writing programs that aren't based on immutability, right? Thinking in terms of immutability, thinking in terms of reductions over events and that sort of thing. And then the trend of polyglot persistence is driving this recognition that there's not the database anywhere. There's many databases, and they all have different purposes, and we need to make sure we can support that. Martin Kleppman wrote a great paper on online event processing where he discusses the polyglot persistence problem. So we've got the infrastructure problem, and then we've also got kind of a people problem. This is unfamiliar. Most people were trained to think in terms of object-oriented programming and just database-first kind of thinking. Product specialists don't even know what superpowers are possible to them if they take this event-first journey and this event-first perspective. And most of all, we lack a sort of common design language and methodology, a way of talking about and describing these systems. We just don't have it. So what my client needed was just that. They needed a common way of thinking about these systems and communicating about these systems and specifying these systems. How do we describe to each other and solicit requirements and collaborate to build the right thing? Ideally, this method and language would be simple so that non-developer stakeholders can participate meaningfully in the design process. We can solicit all of their great expertise about the business problem that we're trying to solve, the business process, the user interface, and the user experience, right? We want to be able to solicit expertise and requirements and design from non-technical or non-developer skill sets. But it also needs to be specific enough so that the developers can directly take this artifact into implementation and start writing working software directly from this artifact. So it can't be so high level and simple that it's meaningless, right? It has to be specific enough to be actionable by the developers. And most of all, it has to be super low friction, right? If you're adopting this new design language, something that's going to be used by a lot of different people, it has to work with the human brain. So it has to be built out of things that the human brain's good at, like narratives and visuals. So what did we have at our disposal, right? If we're trying to select this design language and methodology, what's available to us? This is going to be a caricature. In fairness, this may be a bit of a straw man for these design methods. I know a lot of serious thought and effort has gone into these design methods, but frankly, they just have never worked for me. So we'll talk about that a little bit. So on the one side of the pendulum, there's this sort of big design up front idea. This was born back in the waterfall days where there was this sort of discrete notion of like, okay, design starts here and ends here, and then we move into implementation. A lot of UML techniques, rational techniques around specifying software visually developed kind of during this time and in this assumption of big design up front. But they were too focused on the low-level concerns, the system-level concerns, the nerd stuff, right? Classes and interaction diagrams and class hierarchies and all that stuff. Not enough focus went to the user concerns and the business-level concerns. Additionally, specifically for UML, it's so complex, so specific. The graphical modeling languages have hundreds of visual words. You might as well be writing code, right? So this big design up front suffers from the no plan survives first contact with reality problem. It's fragile and it's unlikely to last throughout the software development life cycle. Agile swung the pendulum all the way to the other extreme, where they talked about no design up front or emergent design, right? If we just test code refactor enough, surely the design will emerge from that. Only it mostly didn't, right? So within a particular application or service, this may work, but when you have a suite of distributed systems, different teams building different distributed components that have to integrate together, trying to build the bridge from both ends and hoping they meet in the middle is just not a good strategy. So additionally, user level concerns dominate, driven by user acceptance testing. And there's not enough thought given to the business level concerns and the system level concerns, right? Consistency, availability, operability. How do we integrate? How do we satisfy business requirements that are inevitably going to pop up here? So this idea suffers from the failing to plan is planning to fail kind of idea. So there has to be sort of this Goldilocks zone in the middle. How do we balance this teleology, meaning like having a goal up front and shooting for that goal, like big design up front, versus this idea of emergence where we learn as we go and we can't commit to a design up front because we don't know everything yet. There is this Goldilocks zone in the middle, lightweight design or small design up front, or sometimes just enough design up front, they call it. And there are a lot of techniques here that have been developed by the domain-driven design and agile communities. Event storming, design thinking, user journeys, and wireframing. A lot of different techniques here. The real key to this, and what I'm looking for in a lightweight design language to share with my clients or to use on my own software products, it has to be simple enough for all the stakeholders to understand, especially non-developer stakeholders. They need to be able to meaningfully contribute to the design. But it also has to be specific enough and well-specified, well-defined enough to be actionable for the implementers and to accelerate the implementation of the system. I'd like for both the process of generating the artifact, like the workshop, and the artifact itself to both be meaningful and useful and to convey knowledge and context among stakeholders, right? There's great knowledge and learning that happens during the workshop, but the artifact itself also needs to be valuable. And it needs to be valuable throughout the software development lifecycle, or else it's not going to be kept current. It's going to get stuck on a shared drive someplace, and it'll never, it'll be a lie after the second day of development, right? So we got to keep it current and up to date. Event modeling, for me, is the technique that strikes this proper balance and kind of scratches all those itches. Event modeling was invented by Adam Dimitruk, the founder of AdaptTech Group, with collaboration from Greg Young, who works with him at AdaptTech. And Greg Young coined the term CQRS and event sourcing. So these are experienced professionals. They've thought a lot about these systems and how to build systems out of events and so forth. Some of the aesthetics and techniques descend from event storming, but it's much simpler and much more solution focused than event storming tends to be. Event storming tends to be about exploring a problem space. Event modeling is all about defining the solution. You can read more at eventmodeling.org. I strongly encourage you to do so. A lot of what is to follow in this presentation are Adam's own graphics and definitions from a great article he wrote at eventmodeling.org called What is Event Modeling? So you can read that. Additionally, in full disclosure, Adam Dimitruk is a special technical advisor to Evidence Systems, so we work directly with Adam. This is what an event model looks like. And we're going to define each of these 4 visual words that you can see in the lower left on the legend. And we're also going to define the 4 patterns that you see along the bottom. We'll talk about these words: wireframe, command, event, and view. So it's a very simple visual language. There's only these 4 elements, these 4 words. And these 4 words are connected in these 4 patterns: state change, state view, external state input, and external state output. So the first element in event modeling is, not surprisingly, events. Events are facts or outcomes that you record along the timeline of a business process. And the set of events needs to be sufficient to describe the whole business process, right? What's the set of things we need to write down as we're observing this business process go by in real life so that we can understand and automate this business process? We represent these events by orange notes, and we write them as a verb phrase in the past tense. So room booked. We can organize these events into lanes, and the semantic of the lanes down in event land are around bounded context or narrative. So a lane maps to a single causal history. And in Kafka, they map basically one-to-one with topics, in my experience. So this is Adam's sort of canonical example app that he uses in his article. It's a hotel booking kind of thing. And here along the center, you see the events. So you've got different lanes for these events: room added, room booked, room ready. These all pertain to room inventory. You've got authentication events where users are registering to use the service. You've got payment events. You've got really low level kind of IoT GPS events. The second element in an event model is wireframe. So a wireframe is just that. It's a visual wireframe. So you can map out and view the user experience from the user's perspective. What do they see? What do they click on? What are the forms do they fill out, et cetera? They don't have to be graphical. These wireframes can also be APIs or automated jobs. But these are the primary kind of touch points where the user can introduce change into the system or perceive the state of the system. That's kind of their view into the system is by way of these wireframes. These wireframes can also be organized into swim lanes, but they have a different semantic from the event swim lanes. Wireframe swim lanes indicate audience or role or persona. So here along the top, you see 2 different lanes of wireframes. We have the guest who will be doing and seeing certain things, and then you have the management and hotel staff that will be doing and seeing other things along the course of this business process. The third element And the first pattern that we're encountering is the command element and the state change pattern. A command encapsulates the intent to change the system. This is empowering the user to take action, and it represents kind of our transactional moment. It's speculative, so we phrase it as a verb phrase in the imperative tense, book room. And we represent it on the diagram as a blue note. And commands result in the emission of an event. So a command is our kind of speculative transactional moment. You see here, user clicks a button on a wireframe after they select a room, and that sends the book room command. In the process of handling this command, probably in our web services tier, we can say, I don't know, is this room available on those dates? Do we know who this user is? We can think about it and do some business logic. We can say no, return with an error and say, sorry, it's not something we're willing to commit to. Or if everything looks good, you can commit and emit this room booked event. As soon as that event is emitted, that room is booked, that fact is true, and everything downstream has to kind of adjust to that. So they've affected the state of the system. The final element is the read model, and the second pattern is the state view pattern. This is about informing the users about the state of the system. We represent these read models as green sticky notes, and these read models are derived from events. They're basically a reduction over some stream of events for a particular purpose. Often they're displayed in wireframes to inform the user, show user data on the screen. But you can have different read models over the same set of events for different data access patterns, for different purposes. That's kind of that polyglot persistence idea. So here we have the state change pattern here with a read model. After a room is booked, one of the things that impacts or affects is this cleaning schedule read model, right? After a room's booked, it has to be cleaned, it has to be made ready for a guest, and so it needs to be added to the cleaning schedule to be shown to hotel staff and management. The third pattern is the external state import pattern. This is where we're listening to events generated elsewhere and incorporating those events into our local context or into our local narrative here. So sometimes those events from elsewhere are lower level system events, IoT events, that sort of thing, or they may be generated by some foreign system in some foreign bounded context from some other application or service that we want to react to or take action to or incorporate into our view of state. So in this example, we have a translator from low-level GPS events. Maybe they're generated by our mobile application, our hotel booking mobile app. But they're not meaningful and not actionable to us as these low-level events. We need to translate them into a guest left hotel event or guest entered hotel event via geofencing. So that's what that translator does, is it incorporates it into our local context, incorporates these foreign events into our local context. The final pattern is the external state export pattern. This is all about causing change in some foreign system. So whereas import is all about just observing what's going on in foreign systems and taking action or building state based on that, the external state export pattern is all about causing change in some foreign system. So we build up a local to-do list of actions we need to take to cause side effects in some external system. And we represent that kind of to-do list or batch of work as a read model. Then some automated process represented by like a gear or automation wireframe invokes commands on that foreign system. And then we emit events that represent the result of that command in the foreign system. So here we can see there's kind of a payment processor integration here. We get payment details from our user. We write those down as an event. Maybe every time that happens, or maybe we batch these things up in windows of a day or an hour or a second or whatever. We have payments to process as a read model. Our little automation reads or iterates over those payments to process, invokes the command in the payment processor gateway, and then as a result, the payment either succeeded or it failed, and we write down the result of that command in the foreign system locally as an event. So that's event modeling. That's how you do it. How do you arrive at that? How do you generate that artifact in a workshop format? This is the workshop, and it's got 7 steps. We're actually going to show you a demo using Evident Systems' own event modeling platform that we've developed called oNote. We're going to show you a demo of that. The steps are brainstorming. You just get the events out there, the plot, you sequence the events, storyboard. You put up the wireframes atop of that event timeline. You identify inputs, so you get the commands up there on the board to connect your wireframes to your events. You identify outputs, that's getting the read models up there, where you're connecting events back up to your wireframes. You apply Conway's law, so you figure out what the swim lanes are up in interface or wireframe land, and down in event land, what are our different organizations, our different causal histories, our different audiences. And then in step 7, we elaborate scenarios. We bang on this model. We do information audits to make sure that we have all the information as it's flowing through the system. We figure out the failure modes. We just sort of elaborate and make sure that we have the whole story. So now we'll show you a demo using oNote of a workshop. We're going to go fast, and we're going to sort of do a time lapse here to show you how a workshop might unfold.
The first step in our event modeling workshop is the brainstorming step. Here we have someone explain the goals of the project, and we start to scope the project by getting all the events up on the board. Here, anything goes. Try to get as much collaboration input as possible. People are going to put down events that are not truly state-changing events, and that's okay. We need to clarify that. But for now, as people get events up on the board, we'll sort them out later and change some things that are actually read models or commands into events in later steps of the workshop. This is all about collaboration. Step 2 of our workshop is quite simple. The idea here is to sequence these events into a plausible narrative, making sure that the causality makes sense. Again, correctness, you don't have to be perfect here, but just make sure that the events make a proper story. Now that we understand the overall story of the system, the next step is to get an understanding of what the user will experience as they interact with this system. So along the bottom, we have our narrative of events. Along the top, we put our narrative of wireframes to envision the customer journey and what the customer will experience in the course of this system. So here we're putting up some very simple mock-ups. We have some data fields that we can name. We have some action buttons. We have some data display or output type controls. And we just sequence these in a timeline so that they roughly match up with the events along the bottom. The other thing to remember about wireframes is not all of them are graphical. We can have APIs modeled out here, and in particular, we can have automated jobs. So if you see this little gear icon, that represents an automated system, not a user, but some automated system that will be doing work on our behalf. As you work, make sure to keep things evenly spaced out along the bottom so that the events and wireframes match up, and to give yourself plenty of room to work for future steps. Step 4 of our workshop is where we identify the inputs to the system. Here we're looking to empower our users and seeing how commands flow from our wireframes through to our events. And we need to make sure that all the data is sufficient, that the originating wireframe can send through sufficient data to the command, which can be recorded in the event, to make sure that we have all of the data associated with the state change. Remember that here we have some non-user wireframes. We have these automated jobs. They also can emit commands. That's how all change is introduced into the system, not just by users. So we can link up, for example, the checkout processor. We can have it send the check guest out command. So here we want to make sure that we have a logical story for how all the change gets recorded in the system. During step 5, we identify the outputs to the system so that we can inform our users and enable them to make good decisions and turn around and issue further actions into the system. So here we make sure that we get all of our read models shown, including those that will provide information to our automated jobs. The goal is to inform our users, both automated and human, so that they can make decisions in the real world and issue further commands into our system. Here we also identify things that are actually read models that we had recorded as events. Step 6 is to apply Conway's law by organizing the events and interfaces in terms of their audience and purpose. So in interface land, we organize lanes of interfaces according to their purpose. On the top, we have managers. On the bottom, we have the actual hotel guests. Down in event land, we organize the events according to their bounded context or their narrative or the story they tell. Finally, in step 7, we elaborate additional scenarios that we weren't able to figure out the first pass. So here we have this guest checkout process error, but we don't know how the guests, we don't know how to detect when a guest has left. So we're going to add some geofencing here. So we have a lane of events at the bottom that are low-level lat-long events that don't mean anything to our system. We translate those events to detect when a guest has left the hotel, which then informs our checkout processor in its decision to check a guest out.
So we've just seen how the workshop works and comes together. This is really about the design part of the SDLC. It's soliciting massive collaboration from across your organization, different skill sets, and you arrive at an initial working design. But as I said before, event modeling is useful throughout the SDLC, not just during design, but in implementation and operations as well. So as you move into implementation, the artifact itself, the event model itself, is very useful in accelerating your implementation. So the first thing that Adam writes about is how event modeling can help with your project management. So an event model can be sliced into these discrete implementation tasks according to the patterns that we enumerated. And user clicks button, sends command is handled, and results in event. That's one developer slice, a discrete implementation task. And the full set of implementation tasks represented in the event model, that represents all the work that needs to be done in order to complete and have a fully working implementation of the system. So you don't need to have a separate user story creation ritual or exercise where we're coming up with user stories. We already have that because it's implicit in the diagram. So that accelerates project management, it makes it easy and transparent. In turn, we can then reflect the completion of those tasks visually in our event model. So at a glance, you can show the boss or whoever with an overlay, here's how far we are in the implementation of this system. So it's a nice visual status report. We can also accelerate the implementation itself. We can generate test cases from the patterns as we're defining the schemas associated with commands, events, read models. As we're generating sample data in the course of building this event model, that will directly feed into test cases. Those schemas themselves, so you can define what data is associated with a command, what data is sent by this command, what data is stored in the event, what is the shape of the data that we show out to our users in the read model. By specifying those schemas, we can get a long way towards some code generation, right? We can define a GraphQL schema or a gRPC schema or a OpenAPI Swagger specification because we have all those data. As we move from implementation into operations, the event model serves as a great tool for data discovery and data integration, right? Again, we've got these lanes or topics of events, and we know the schema associated with each event. So we can integrate with the schema registry or a stream registry if you have one. We can discover what data is generated by other applications so we can incorporate those into our applications and our analyses. It also supports other types of cooperation within the enterprise. Inevitably, as I said before, someone always wants to see your data. Someone always needs to understand how your system works. So IT operations, if there's an incident, they need to understand where the problem is and where the data is not flowing. For design reviews, to incorporate your application's capabilities into another application or service, the event model serves as a very clear communication tool for understanding these systems. It also really helps, and Adam writes at some length, about InfoSec and compliance auditing. So especially security auditing, it's very clear what data is flowing where and how everything works in your system so you can do an InfoSec audit. So there are some challenges that we've encountered in practice, both internally at Evidence Systems and with our professional services clients. The first big challenge is to assemble the right room during the workshop phase. You really want a diverse skill set. So of course, software engineers and architects, but also UI UX designers, business process experts, even potential users of the system if it's an internal capability. You also want a diverse set of levels from your org chart. You want the people who are doing the work, their bosses, and their bosses' bosses. So you want, a good representation. I've run constructive event modeling workshops for as many as 50 people before. There's also sort of a challenging trade-off between analog event modeling and digital event modeling. Analog's great. That's where you're in a conference room with sticky notes and Sharpies and butcher paper and all that. It's highly interactive and collaborative. There's a ton of learning that takes place organically, and context is getting transferred from business people to tech people and vice versa. It builds trust within your team and among the various cooperating teams. But the artifact itself is a bit of a letdown. At the end of that, 1 day or 2 day event modeling workshop, boy, we got this piece of butcher paper covered in sticky notes connected by arrows. And it's like, what do we do with this, right? You got people out taking panoramic photos with their mobile phone, and you've got people trying to move the butcher paper to the dev team room, and like sticky notes are raining down like autumn leaves. And the whole thing, it's not great. It doesn't transition especially well to implementation. So digital definitely takes the cake there. The other thing is COVID-19 has canceled conference rooms. So we don't get together in the current moment like we used to. Fortunately, unlike other workshop formats like event storming, event modeling was explicitly designed to be remote friendly. So in-person is great if you can do it, but remote is also super productive, especially if you have the right tooling to support your remote and digital event modeling exercises. So event modeling tooling, kind of the state of the art. Adam has this great Slack channel and this whole community he's built of practitioners of event modeling. And a lot of those folks use like collaborative whiteboards. They're okay. They're not purpose built for event modeling, so you can just draw whatever picture. So without careful and rather active facilitation of that workshop, boy, you can end up with something that's not an event model. It's just some arbitrary picture of something. And it doesn't really transition well into implementation operations because it is just a picture, right? You're not capturing schema. You're not capturing some of the more technical specifications of this thing. So at Event Systems, we built our own collaborative event modeling platform called oNote. There's a free version available right now. You can go to oNote.com and sign up today and use it for free. Within the next 6 to 9 months, we will release an enterprise version. We're working with early enterprise customers now. And we will also have a paid solo upgrade so that free users can upgrade to a paid version that will remove any limitations and give you access to some of the enterprise features. Those will be coming soon. We built that because of this disappointing letdown moment at the end of an analog event modeling session, as well as kind of a lack of support for tooling. We wanted to build a platform that would help companies really communicate about event-driven information systems and design them well. So in conclusion, event modeling is a great shared language for designing and building information systems, any information systems, but especially event-driven information systems. And these the artifact that comes out of that and the learning that comes from event modeling is useful across the software development lifecycle. So certainly during the design phase, you've got the workshop and a ton of great learning happens there. But throughout implementation and operations, there's huge advantages to having a clear design. Having coders code in the presence of a design is orders of magnitude different from them coding in the absence of a design. So it's very useful throughout the SDLC. If you're interested in event modeling, check out our event modeling platform, oNote, at oNote.com. Sign up for free, start using it and playing with it. We do professional services around event modeling, and AdaptTech Group does some great professional services around event modeling and implementation of these systems. So please get in touch with your local event modeling expert. And thank you for watching my talk. I hope this is useful to you.